Hey guys, we're going to go ahead and talk about scientific notation is what it's called. And before I really start talking about that, I want to show you guys a couple of different numbers. And because, in science, you use a lot of math, you use a lot of numbers. So we live in the Milky Way galaxy, and if you were to sit very patiently and start counting stars, that number right there, 200 billion, is approximately how many stars there are in our Milky Way galaxy. 200 billion, very big number. The most important star to us, of course, is the sun. And the sun is mostly made of hydrogen, right? And if you were to take all the hydrogen and weigh it from our sun, it would weigh this much in grams. If you can see all of those zeros. An enormous number. I'm not even going to try to make up a word for that number. So it's quite large, but when you think about other things about this, hydrogen is quite small. Hydrogen is a very small atom. And if you want to know how much does just one atom of hydrogen weigh, it weighs this number in kilograms. And I want you to notice that this number is very, very small. I have a decimal point right there, and then all these zeros that follow it. So the reason I'm showing you these numbers is because in science, we oftentimes are dealing with things that are very, very big or very, very small. And dealing with those numbers can be difficult. How would you like to have to write this number over and over every time you want to talk about how much hydrogen weighed? You wouldn't want to. So there has to be a simplified way of doing this, and that's where scientific notation comes in. So what I'm going to do is show you how it works, and we'll kind of go from there. All right? Okay, so the best way to explain scientific notation is right through an example. So I'm going to write out a number. This is scientific notation right here. 2.5 times 10 to the 5th power. Okay, let me try it again. There we go. 2.5 times 10 to the 5th power. I want to identify what all these parts are. So this right here, the 2.5, is called a coefficient. Okay? Coefficients are always going to be somewhere between the number 1 to 9. So it might be like 1.01, or it could even go above 9 a little bit, like 9.27. It's always going to be a number where the whole number is somewhere between 1 and 9. Okay? And we'll talk more about that. This right here is called the base, and this up here is called the exponent, also referred to as the power. So you heard me a second ago describe this as 10 to the 5th power. So let me explain how this all works out mathematically. What this all simply means is this. 10 to the 5th power is the same as saying 10 times 10 times 10 times 10 times 10, 5 times. And if you do that math, it becomes 1, and count the zeros, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So saying 10 to the 5th power is just saying multiply 10 by itself 5 times, and you get 100,000. Now, you take your coefficient, 2.5, and multiply that by the 10 to the 5th power, and you get 250,000. So scientific notation, 2.5 times 10 to the 5th power, is the same as saying this right here, 250,000. Okay? So it's a simplified version. Now, let me show you another example of how we can do this. We say a much larger number. I'm going to change my number just a little. 2.5 times 10, instead of the 5th power, I'm going to go 10 to the 8th power. I just increased in 3 orders of magnitude from 5 to 8. Okay? Now, I could do that whole thing again, 10 times 10 times 10, 8 times, and then multiply it by 2.5, but there's an easier way. Let me show you the easy way. I love easy ways. You write 2.5, and if it says to the 8th power, that simply means move this over 1, 2, 3, 4, 5, 6, 7, 8. Put the decimal right there. Add the zeros. And 2.5 times 10 to the 8th power is 250,000,000, or 250 billion, right? Which just so happens to be that number I showed you a minute ago, the number of stars in the Milky Way galaxy. So we could simplify that just by saying 2.5 times 10 to the 8th. Okay? One more I want to show you. What if I wanted a very small number? I could do the same thing. 2.5, there's my coefficient, times 10, there's my base. But instead of it being a big number, it's going to be a small number. So my exponent is going to be a negative. I'll say like negative 8. All I have to do here, again, very simple. Make my 2 a little better. You go 8 times, but since it's negative, we're going this way to the left. So I go 1, 2, 3, 4, 5, 6, 7, 8. Put my decimal right there. 0, 0, 0, 0, 0, 0, 0. So 2.5 times 10 to the negative 8th is 0.000000025. And that is how you do scientific notation. I'm going to end by showing you those numbers again from the beginning of the video. So here's our 200 billion stars in the Milky Way galaxy. And you can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros after the 2. Now I can write that in scientific notation as 2.0 times 10 to the 11th. That would move 11 spots over. Here's the number, the grams of hydrogen in our star. Right? You could take my word for it. There are 33 zeros after that too. So we'd write it as 2.0 times 10 to the 33rd grams. Okay? And here's the mass of 1 gram. Now there's 27 zeros in between the decimal and the 1. So I could rewrite this. Remember, the coefficient has to be between 1 and 9. So I'm going to write my coefficient as 1.67. Right? That's coming from right here. And then the decimal was moved 27 times in this direction, so it's 1.67 times 10 to the negative 27th power. Right? Now in class, I'm going to give you examples to work on. I'm going to give you something like this, and I'm going to say, okay, write it out as a real number. So you'd write something like this. Or I'm going to give you something like this and say, okay, write it out in scientific notation. I want to see you be able to do that both ways. And then in class, I'm going to also teach you how to do addition and subtraction of scientific notation, and multiplying and dividing scientific notation, which is a little different than your typical adding, subtracting, multiplying, dividing. So we'll see you in class.